In this tutorial, we're going to be talking about the Graham's law. So the Graham's law would be applied to the diffusion and the effusion, and I'll talk about what the difference between the diffusion and effusion is in a minute, and we'll also mention what a mean free path is. Okay, so like we have said in a gas, the molecules or the gas particles are always moving in random directions and they're going to be colliding with one another. So what's the distance, what's the average distance going to be before the molecule collide with another molecule is going to be called in a mean free path. So it's just more like a conceptual thing if you want to make sure you know what mean free path terminology is. Okay, well, let's talk about diffusion and effusion, and that's what's more important in this Graham's law. Um, the diffusion is actually a process of gas spreading in according to the concentration gradient. So, like for example, if you have a room filled up with the gas, and then all of a sudden you open up that room in all four directions, so the gas concentration outside that room is very small. So the gas is going to go from a higher concentration to a lower concentration, and that's just the concentration gradient. So how fast a gas can move is called a diffusion. Now, logically, what do you guys think if the gas is, if it's a lighter gas or a heavier gas, who's going to move faster? So let's say if I have CO2 versus NH3. So what do you think? What do you think? Who's going to move faster? And it really depended on the molar mass, actually. Just like if you have two guys, one is heavier than the other one, it's very likely that heavier guy is going to move slower and the lighter guy is going to move faster. So same story. It actually depends on the molar mass. So this CO2, when I calculate the molar mass of this, it comes out to be 44 grams per mole. And when I look at the molar mass of this NH3, it's about 17 grams per mole. So since NH3 is lighter in mass, it's going to move faster. So it's going to move faster. So I'll just write in there and move faster. Okay, now what's the effusion? The effusion is just the escape of a gas from a container through a small hole. And it still applies the same rule. If you have two gases in the container and they both have the ability to kind of go through that small hole, the gas with a lighter mass will move out quicker than the gas with a heavier mass. So make sure you know the difference between the diffusion and the effusion. So let's put this into a perspective of an equation. So if I have two gases, or if I have a gas, the speed of the gas is actually inversely related to the molar mass. So I'll just write down mm, which means we're talking about the molar mass. Okay. If a gas is lighter, it moves faster. If the gas is heavier, it moves slower. So that's what this inversal relation really means. What's more important in this case is comparing the speed of two gases. So if I have two gases, suppose gas A and gas B, so the ratio of the speed of gas A divided by the speed of gas B is actually going to be equal to the square root of molar mass of gas B divided by the molar mass of gas A. Now keep in mind the speed and the molar mass must be inverse with one another, so that's why if I put the speed of gas A on the numerator here, then the molar mass on the other side of gas A must be in the denominator. Then you need to have an inverse relation. So a lot of time you actually this equation right there to solve problems that's related to the diffusion. Okay, so let's actually look at this problem here. It says at room temperature, acetylene C2H2 has a velocity of 480 meters per second. At the same temperature, an unknown noble gas has the velocity to be 267 meters per second. We got to figure out what the molar mass is going to be for this unknown gas. So, well, I'm going to call this acetylene to be, let's say, gas A, and call this unknown gas or unknown noble gas to be gas B. So I would say the speed of gas A divided by the speed of gas B is going to be equal to the square root of molar mass of gas B divided by the molar mass of gas A. Okay, so let's see what we know so far. I know the speed of gas A, which is acetylene, so that's going to be 480. So let's go ahead and plug those values in. So 480 meters per second. And I also know the speed of gas B, which is going to be 267 meters per second. I'll set that equal to their molar masses. So I don't know the molar mass of gas, unknown gas. So I'll just leave that as it is. So molar mass of B, and divide that by the molar mass of acetylene, which is gas A. Well, we need to figure out what the molar mass of acetylene going to be. So it's C2H2. I got 2 carbons, so it's going to be 12 times 2. Plus, I have 2 hydrogens, so it's going to be 2 times, hydrogen is almost 1. You don't have to write down 1.008. So that comes out to be 26. So I'll go and write that down here, 26. And then from here, you have only one unknown, and you got everything written in the form of numbers. So it's more or less solving the mathematical problem here. So I'll do 480 divided by 267, so that comes out to be 1.80, and that's going to be equal to the square root of the molar mass of gas B divided by 26. And how would you get rid of square root? Well, I can square both sides. So let's square both sides. And when I square both sides, so let's take a square of 1.8. So 1.80 squared is going to be 3.24. And that's going to be equal to the molar mass of gas B divided by 26. So your molar mass of gas B, which is the unknown noble gas, is going to be 26 times 3.24. If you have a different way of solving this math portion, that's going to be completely okay. So times 26 is going to be about 84.24 grams per mole. Okay, so the question actually does tell you it's an noble gas. So you may want to go back and look up in the periodic table and see which particular noble gas has this molar mass. So when I look at, let's see here. So keep in mind where noble gases are. Your noble gas is going to be the very last row of very last period in the periodic table, which is either you can call that group 8 or 8A or group 18. So I see krypton is about 84.9, so it seems like it's going to be a krypton as your noble gas. So I'll just go and write that down here. All right, so hopefully this video was helpful. If you have any questions, feel free to leave any comments